example for which a dot b is equal to c dot b, but a is not equal to c. All of these are vectors. And to gain some insight into this problem, you see that b here is fixed. So you can just draw a certain representation for b. And now you have your two vectors a and c, sorry. So if a is in this direction, if a looks like this, and a and c both have the same magnitude, just to make things easier, we're doing this. If both have the same magnitudes, if a and c, let's say, both are 5 units, then you can see that a dot b, it will be equal to the magnitude of vector a times the magnitude of vector b times the cosine of the angle between them. Let's name it as theta 1, and the other, let's name it as theta 2. And the right hand side will be vector c times dot vector b. That will be this magnitude of c times the magnitude of b times the cosine of the angle between b and c. Since we have taken the magnitude of a and c to be equal, a and c magnitudes are equal, b magnitudes is already equal, that's pretty common sense, then the only barrier is in theta 1 cos and theta 2 cos, these two becoming equal. And so if theta 1 is equal to theta 2, our problems are resolved. So to make things even simpler, let's just take the coordinate plane, and in that let's take b to be the vector I hat. So b is the vector I hat. And now you need to choose two vectors. A and c, so that they both have the same magnitude, and make same angles with b, and we would be done. And the easiest way to do that is to just take the other unit vector. So if you take the unit vector j hat, this makes an angle of 90 degrees. So I hat dot j hat, that is equal to 0. And if you take just the other vector, that will be 90 degrees in the opposite direction. That would look something like this. Then I hat times negative j hat. Again, these two are at an angle of 90 degrees, so this is again 0. But j hat and I hat are not equal, and so an example, the answer to the question, a really simplified answer would be if b is equal to I hat, a is equal to j hat, and c is equal to minus j hat.